All right. Hey, guys. If you haven't already, go ahead and get out your note-taking guides. We need to go through 8.2, which is on page 228. So 8.2, page 228. We've already talked about this a little bit, looking at what it means to be similar. Similar figures are same in shape, but they're often different in size. So we'll write that down. They're the same in shape, but different in size. If two shapes were the same size, we would call those congruent. That's one of the main things that we have to be really careful about when we're looking at this new section. And really, it's the entire chapter 8. Similarity is very different from congruence. If I had a shape that looked like this and another one like this, I would tell you that they are exactly congruent if all of their sides were the exact same length. This tells us that these are congruent figures because all three sides are identical. However, if I told you this, and I told you that all of the angles were the same, I can't confirm that these are congruent. You could have a 30, 60, 90 triangle that's really small, and you can have a 30, 60, 90 triangle that's really big. So the top is an example of what it means to be congruent. The bottom is what it means to be similar. Similar means they have the exact same shape, but they could be like scale factors of each other. We often are going to use this word called proportional. To be proportional to each other just means they have a similar ratio. If you could shrink one down or stretch one out, they would be the exact same shape. And they would lay on top of each other if you could get them to the same size. A similarity transformation just means that it preserves shape. So the angles aren't going to change. You might change the length of sides, but you're going to change them proportionally. If you change one side by 2, you have to change all sides by 2. And that's really what similarity transformations mean. When I change it, I have to change them the same way. So it's going to preserve the shape. You can't just change one side. What we say is we have angle-angle similarity, and that just means if two angles of a triangle are congruent to two angles of another triangle, then the two triangles are similar. Let me read that one more time, because a lot of times when we read textbook definitions, they just kind of go over our head. If two angles of one triangle are exactly the same as two angles of another triangle, then we guarantee they're similar. Remember, we're talking about this word similar, not congruent. This triangle is clearly smaller than this triangle. But that doesn't mean they're not similar. And in fact, because they have two angles that are similar to each other, two angles that are congruent in both triangles, we know that these triangles are in fact similar. They would be what we call proportional. So yeah, that's angle-angle similarity. That's really what drives all of the rest of our work problems today. Let's do a couple examples. We are going to work through something called a similarity statement. We've already done congruent statements. It's the same thing. It looks the same, except instead of using the congruent symbol, we're going to use the similarity symbol, and I'll show you what that looks like in a second. So the first thing it says is check if these triangles are similar. So step 1, check if the triangles are similar. So what I am going to do is I need to solve for the triangle. I obviously have 15 degrees. I have 90 degrees. And then I need to just make sure I know what angle C is. All triangles add to 180. So I do 180 minus 15 minus 90. And it tells me that this must be 75 degrees. Okay, so I know what all three angles are. I can already see that this is 75 and this is 90. I don't have to find it, but just because, we're just going to go ahead and find that third angle and show that it's 15. What you can see is once we have two angles that are similar, then I guarantee, or two angles that are congruent, 90 and 90, 75 and 75, I can guarantee the third angles have to be congruent as well, which is 15 and 15. So I would say yes, they're similar because of angle angle similarity. Angle similarity says I have two congruent angles in both triangles, therefore they're similar. Now it does want me to write a similarity statement. I'm going to call it ABC. We have to be really cautious about how we label this. You could call it whatever you want, but you have to follow that same trend when you write this second triangle. So I decided to write ABC just because it was alphabetical. I'm going to use this tilde symbol, which is just kind of like a curly squiggly. It's like congruent, you just don't have the equal sign on it. So this says triangle ABC is similar to triangle. Well, I need to figure out what matches with A. 90, remember we call that corresponding? 90 degrees goes with A, so that means that E would go first. I know that 15 degrees goes with B, so that's where F would come into play. And then obviously we'll finish with our last one, and that would be D. So notice how the question is asking for a couple things. One, are they similar? If they are, write a similar statement and then explain. So there's kind of three things to write here. Yes, they're similar because angle similarity. And here's the similarity statement. One thing I have to just say it one more time. I know I already said it. I need you guys to recognize A is 90 degrees. Therefore, E matches with it. I have to have the same order. If I go from A to B, that's this side, that's the 90 degrees to 15 degrees side. Same thing, E to F. These always match. So just be cautious, order does matter. We're going to look at number 2 and do a very, very similar thing. I have 44 and I have 30. So I take 180 minus, we're triangles, so they always add to 180. It gives me 106 degrees. I see an issue right away. This is 106 and this is 30. This is 116 and this is 30. That means that this one is not going to match up. I can always double check that. And when I check it, I get 34, not 44. So these are not similar. That's all you need to write. They're not similar. You don't need to explain anything else. They're just not similar. Show that the triangles are similar. Okay, well, we got to know what these symbols mean. I've got parallel signs, and I guess I kind of just spoiled it there. These are parallel. Way back when, we taught you guys something called alternate interiors. If you have two parallel lines and a line that crosses, you can have alternating interiors. We also taught you that if you have parallel lines and something crossing, so again, say that these are parallel, you can have something called corresponding if they're in the exact same spot. So this is kind of that Z shape called alternate interior. This is in the same exact spot, bottom right. We call that corresponding. That's what this problem's getting at. You could claim that angle A is guaranteed to be the same as angle B due to corresponding angles. You could say angle E has to be the same as angle D because, again, those are corresponding angles. They're in the same exact spot on two parallel lines. So maybe angle A equals angle B. If we want to be more exact, we could say it's congruent. Use the little squiggly sign. Why? Because of something called corresponding angles. I could say the exact same thing for E and D. But I could actually do one more thing. I want to make sure that we point this out. This alone would be enough to prove similarity because we only need two congruents. But I do want to show you one more thing because it's really helpful. I want you to check this out. Angle C. What's going on with this one? Both triangles, the smaller one, the smaller triangle, and the bigger triangle, they share angle C. You guys may recall that whenever we share the same thing, that it's called reflexive. So you could use any two of these three things to say, hey, they're similar by angle similarity. You would have to have these properties down though. Let me show you number 4. It's a very, very similar process. Here we have that Z shape that I was going to reference earlier. We have a Z shape, so I can guarantee this angle and this angle. And I would write alternate interiors. I could do a Z shape in another direction. Watch the red. There's a Z shape. So I could claim this one and this one by, again, alternate interior. In reality, on a quiz, I just need you to say something like, hey, by correspondings and by reflexive. I need you to say, hey, by alternate interiors. We would guarantee that those are similar. On the next page, this example, it's fine. I think it's a good worksheet challenge problem. I don't think it's awesome for notes. I think there are better ways to go through this. What it's trying to get you to recognize is, are these in fact similar? Where it tells you, look, this entire distance is 3. And if this section is 3, then this section is 3. Which means the entire distance is 6. So we got some proportionality going on. We have 3, we have 6. We have 3, we have 6. So things are kind of doubled. I could use that to then go do some Pythag stuff. I want you guys to recognize that we've got a 90-degree angle. I'm not going to go through and solve this whole thing out. Because again, I said I think it's a little bit beyond what I want you to do for our notes today. But notice that yellow triangle, we've got a side of 3. We've got a side of 6. We could go through and do Pythag to find the distance of AG. This is totally something that we would expect you to do. Be able to take your side squared and go find what your hypotenuse is. We're going to call that C. So solve and square root and do everything that you got to do to go find what C is. I'm going to hold off on showing you guys this example all the way through just to save a little bit of time and notes. Like I said, I think there are some good, kind of more simple worksheet problems that you guys will be able to practice with when we transition to that. Let's do something like 15. It says, is it possible for these to be similar? A lot of students struggle with this question for obvious reasons, and I think the number one reason is we just don't have a picture. So let's draw a picture. I'll just make 2 triangles, and I'll call it H, J, K. And then I'll draw another picture, and I'll call that one PQR. And I'm just going to label it with the information they tell me. It says angle H is 100. It says angle K is 46. Angle P is 44. And angle Q is 46. So that's all that they give us. And they just ask and they say, is there any way for these triangles to be similar to each other? Well, you would just want to check and see if they have 2 congruent angles. Remember, the driving property today is angle-angle similarity. If you can prove you have 2 congruent angles, you can prove that these are in fact similar. So just find the missing angle. Go figure out what angle J is. If I use 180 minus 100 minus 46, I get 34 degrees. And go find this one. 180 minus 44 minus 46. I get 90. I know it doesn't look 90, but that's okay. I think it's pretty obvious I don't have congruent angles. So I don't have 2 angles that are congruent, so you would say no. It's not similar. And you don't have to explain if you draw me a picture. If you guys are on a quiz and you just wrote not similar, I wouldn't take that as an answer. You would need to show me a picture. So when you guys get these and there's not a picture, it's really helpful. Just draw 2 triangles, HJK, PQR, kind of label it, and then it's a lot easier to see what's going on. All right, y'all, I appreciate it. I need you to go ahead, get into your worksheet. This is going to be due tomorrow. Good luck.